Um, my name is Kevin, calls W3KKC, been licensed about 40 years, and I own Masters Communications. We started building sound cards back in 2014, and not for digital radio stuff, but for analog radio stuff, and then it adapted into that as the years have gone by. So that's what we do. We build sound card interfaces that are designed to connect computers and two-way radios together with minimal hassle and cost while providing maximum value and performance. For those of you that want to follow along at our website, we're located at masterscommunications.com. So what are they, and where did they come from? DRAs are radio optimized sound cards that connect two-way radios to a computer to convey digital data communications. The DRA series may be used for digital radio applications running under Linux, Mac, or Windows operating systems. DRA series interfaces are the result of re-engineering the very successful RA series All-Star Link radio adapters. So just real quickly, you'll note in some of the applications, there are still references to RA board, like in VARA FM and VARA HF, you'll see RA board. And the reason that it doesn't say DRA board is because when we first started doing this, we had a couple of RAs that we customized and made work for digital communications, and those are really what made us start producing the DRAs. So why should we use a sound card digital mode? Most digital modes are available using, a sound card interface. So there's a lot of applications that can't use anything else. So it's certainly a way to do probably most of the applications that are out there are supported with a sound card digital mode, and some of them are only available that way. They can be less expensive and may even be built into the transceiver. These days we have some higher end transceivers that do have the capability of being able to be used with the sound card digital modes, and you don't need to buy anything else. They've got a completely capable sound card built into them. One of the big reasons that we use a sound card is it is superior data decode performance over dedicated hardware. A lot of people wonder about that, but certainly there's been a lot of testing done, and I think with this latest version of VARA HF that shows that we can use a sub $100 sound card interface and have almost as good a throughput under the same kind of conditions as some hardware that costs $800, $1,000, $1,500 or more. I think that's impressive, to say the least. I keep doing that, I apologize. Here's a block diagram that basically shows what this thing does. It takes data from the computer and goes through a bunch of different blocks that changes the analog signal into a digital signal. So digital communications from the standpoint of the radio is kind of a misnomer, because we're not really producing a digital waveform like what you may see with a DMR radio, where you're actually transmitting a digital waveform to another radio. We're not doing that here. We're producing an analog signal that represents a digital signal as it becomes transcoded at the computer. the sound card operation. So basically it's a simple interface. It's not a TNC. So it doesn't do the same functions as a TNC that certainly the sound card and the computer together do, but the sound card itself does not. It may provide ground isolation between the radio and computer. It certainly can provide a push-to-talk signal. Doesn't always have to, but it can. It does not process the modem signal. So again, in this instance, we're not taking the signals, and in the case of the sound card, it's not what creates the digitalness that the program operates on. Certainly the sound card changes things into digital, but it's not what the program acts upon, or in this instance, what a TNC would act upon. That's all done in the computer. So it doesn't process the modem signals. Signal processing is done by the software running on the computer. It may include additional ports for rig control. DRAs don't do that, but there's certainly more sound cards out there than what we have available, and some of them do have rig control built in. The host software does the signal processing, the modulation, demodulation. That's what modem stands for. Mo for modulation and dem for demodulation. Provides the timing and the data control signals to operate the the functionality between the radio and the sound card, and also the data protocol. So what applications do they work with? And there's a little bit of history behind this. When we first started building these kind of radio interfaces, there was only one of them that had the ability to make the push to talk work with the chip that we're using, the C-Media CM119, and that was VARA FM. Since then, all of the flavors of VARA have incorporated the push-to-talk capability. So with that, we have supported modes here are RDOP, VARA HF, VARA FM, wide or narrow, just about any kind of packet that you can imagine. Using UZ7HO sound modem is a really, really good program to do the regular AX25 packet. And of course, VARA Chat, VARA AC. FL Digi about a year and a half ago incorporated C-Media push-to-talk. We already talked about RDOP. Dire Wolf now for all of the different flavors. It used to just be under Linux, and now also Windows is supported. PSK, FT4 and FT8 with WSJTX. That does require currently a Vox-capable DRA. That C-Media push-to-talk hasn't been ported into that software yet. And likewise with the SSTV application with MMSSTV, still requires a Vox-capable DRA.
There's also a software workaround that you could do, but it adds complexity to the configuration, but you can also do it with software as well.
So getting to this C-Media hardware push-to-talk, this is really the big difference between the DRA and most other sound cards that are out there, is the way that the push-to-talk is created by the sound card. So many radio devices derive and generate the push-to-talk by the detection of audio, and that data or side tone is detected by the Vox circuit, and that's what generates and keys, generates the push-to-talk signal and keys the radio. DRAs don't work that way. When we're using a native program like VARA FM, VARA HF, whatever, those programs now include the ability to set up using the menu, the ability for the sound card to generate the push-to-talk, and it does not require a Vox-capable DRA anymore for many of those applications. And basically what it is the program is written that it changes the state of a GPIO in the codec, and that state of change biases a transistor, and that push-to-talk signals what is used then to key the radio. So the big deal is the the fact here that it's totally independent from the existence of audio and audio level. So audio is not what creates the push to talk. This is done as something is asserted from the program and says, hey, I want the radio to transmit. Whether there's any audio being developed at that instant or not is irrelevant. And that brings up a really neat thing, because some of our DRAs have an awful lot of audio, much more than what you need. Well, in this instance, because push to talk is not tied to the existence of audio, you are then free to turn Windows speaker volume level down. You can turn it down to a fraction, 1%, 2%, whatever. You can always get rid of audio, but sometimes it's really tough to be sitting there wishing for more. And that's one thing about a DRA. You never wish for more audio because there's always plenty. And there's always ways to get rid of it. So with a DRA, we try to encompass more radios, be able to be compatible with more radios. Certainly some of them do require more audio. And for those ones that do, we accommodate them.
Yeah, and Kevin, another thing to point out here, which I think is significant. The other way that we can generate hardware push to talk is utilizing a COM port. That's kind of the more traditional way that's it's been done in the past. So you toggle one of the leads in a COM port, and that drives a transistor similar to what we're doing here with the C media. By using the GPIO port and the codec, and GPIO, by the way, is general purpose IO line. So those can be assigned to whatever the programmer decides to assign them to. In this case, we're using one of them for hardware PTT. That presents itself to the operating system as a human interface device, or an HID, which is like a mouse or a keyboard. And those things are inherently shared devices. So when you've got a COM port generating your PTT, only one application can use that at a time. Whereas an HID interface that we're using here in the C media device is a shared thing, and it can be utilized by multiple applications at the same time. So I can have RFM up and I can have UZ7HO up both at the same time, and both sharing that hardware push to talk interface.
Yeah, so thank you for reiterating that there's much more to this than meets the eye. So anyway, we've already pretty much discussed this. These are the applications that have this capability. But just to reiterate, there they are again. So why should we consider a DRA over something else? And the answer to that question, real quickly before I get into the talking points here, is over time I have come to the realization that the DRA's big advantage is under two things. One of them we've already talked about, and that's the ability for the device to create the push to talk from a command out of the program, and that's not tied to an audio level or a Vox. When that is all that you have is Vox to create the push to talk, there is an inherent delay for the radio interface to realize that there's audio, understand that there is, and then create the push to talk, and then that has to make the radio transmit. There is an inherent delay in doing that. There's also a delay that whenever the audio disappears, that the Vox has to say, oh, well, the audio's now disappeared. I probably should shut the transceiver off, shut the transmitter down. That takes time. And that delay can impede the ability for the program to talk to its neighbor and do the handshake back and forth. And in fact, if that relationship is too slow, it will not work. It will fail. So certainly the push to talk gives us the ability to transmit back and forth, the relationship of the handshaking very quickly. Besides that, the second biggest thing is, and this happens more so on VHF and UHF than HF radios, we have higher throughput capabilities because of two things. The amount of the audio that's available and also the quality of the audio that's available. Unlike some radio interface manufacturers, we don't use transformers unless we absolutely have to. And none of the DRAs have them built in. The mixer is going to have a transformer option so that it can be connected to commercial radios. But for the most part, we try to stay away from transformers. Transformers can create a lot of problems, and especially for any application that's using QAM. Quadrature amplitude modulation has two distinct points to it, and that is amplitude and phase. And unfortunately, a transformer can ruin both of those. So a lot of the times that people are having problems with higher speed throughputs, it's because of transformers, and it's not because of their frequency response. It's because of a situation called group delay. I'm not going to get into that tonight, but it's something for you folks that are technically inclined to look up. So anyway, we ensure the highest throughput because we don't have transformers, and there's plenty of audio available for those hard to modulate radios. Some of those radios that are hard to modulate is, I own a Yaesu FT8800, and the DRA50 was created distinctly for that particular radio. It requires over 2 volts peak to peak of audio, and that's not available from most of the other competitors that are out there. They are high quality, they are hand built in the US, and generally are lower cost. So the DRA series, we use high quality components, and the printed circuit boards are custom engineered to ensure the best performance. I actually do all of my own printed circuit board layout. I've been doing it for many, many years, and I've hopefully gotten good enough that we can continue to build really, really good stuff from, the ability to be able to do that in-house, not have to outsource that. So we have lower total cost of ownership as compared to a similarly capable piece of equipment from our competition. And from that, I mean, if you only need a DRA 30 for a particular radio, you're not spending $150 or $175 for a built unit. It's much less than that. And so, you can get into this and possibly not spend, an arm and a leg. The third thing is our assembled and tested units are FCC Part 15B certified. These were tested in a lab. They were not just simply declared. There are a lot of companies out there that say that they have, say that they are Part 15B, would pass that certification, but they really didn't do the certification. Our products were taken to an independent lab and tested in a quiet room, and we know that they will absolutely pass. Some of the other things that the DRAs do is we have this is really important for deployments that are at repeater sites or remote locations where they're going to be unmanned. We have a stuck push-to-talk protection. This includes a heartbeat monitor, and it eliminates inconvenient trips to a radio site to kill a stuck transmitter. It basically is a little watchdog 555 timer circuit that are on all DRAs, and it simply watches for the communications from the computer. And if the computer stops communicating with the device, it kills the capability of the DRA from creating a push-to-talk. So never will you have a DRA sitting there having a radio keyed when the computer's off doing something that it shouldn't be doing. So transmit audio level is another difference between the different models of the DRA. The lower models, the 30, 34, 36, and 39 have the reduced amount of output capability, and that's certainly adequate for a lot of radios. You know, if you're stuck with having to connect the DRA up to a microphone and speaker connection or whatever, that's great. Some radios like ICOMs, they don't need a lot of audio on their data ports, and the DRA 36 will work absolutely fine with a lot of the ICOM radios. So most of our other DRAs above model 39 include amplifier stages for higher output capability. And again, the reason for that is some of those require a lot of audio on their 9600 input. And certainly all those models that are listed there have that additional amplification to make that happen. So other features. These things are small, relatively small in size, and you know, they're really good for sticking in a Go box or whatever. They have status LEDs to tell you what's going on with them. Again, no transformers, reduces that group or phase delay for QAM protocols. Transistor keying, which works with 99% of the radios. However, there are some. I own an ICOM IC706 Mark II-G, and it will not key with a transistor. Got to have a relay. So we have a DRA 52. If you like DRA 50s, the 52 is identical to the 50, but it has a relay. And all of the higher models, the 100 and the DRA SR, they also have the relay to key any radio. They'll work with any of them. So we have 3 different types of radio connectors available. A lot of people say, well, why do you have 13 different radio interfaces? Why don't you just build one? We do have one that works with every radio out there, but it's $175. What if you just want one for a Bofang UV5R? You can buy a DRA 39 and you buy a cable and a module from Tigertronics, because we have some of these units that can use or reuse cables from our competitor. And for a lot less than $175, you can be on VARA FM and it works great, and you don't have to spend $175. So anyway, we have lots of different radio connectors available because not all radio manufacturers use the same kind of radio connector, and it's just, you know, to try to match stuff is really the reason. It's easier for us to do that. Granted, from a support standpoint, it makes it harder because we're building all these different interfaces, and somebody comes to the site and they're like, oh my goodness, there's 13 of these things and I don't know which one to buy. Call me or email me. I'll be happy to help you. They have solderless configuration headers and jumpers. So most of this configuration can be done. You don't need a soldering iron. You don't have to know how to solder. It's just movable mechanical jumpers to make most of this stuff work. Plastic and metal cases are now available for all the models. I shouldn't say plastic models. Plastic cases are not available for all models. So this statement, Scott, I see we've messed this up.
Yes.
So we have plastic and metal cases available for all standard DRAs, and metal cases they come standard with our high performance DRAs. So I apologize. We'll have to change that. Anyway, they're made in the USA. And ironically enough, all the people that build for me are on this meeting. So everybody understands that these are all built from people that are hams, and they're built here in the United States. And we do that with as many United States sourced components as possible. Unfortunately, the best capacitors are made in Japan. So that's where we source our caps from. There are a few components that I have to buy from China. I don't like to do that, but it is what it is. But we certainly do try to obtain all of the components that we can from the United States. I I spend a lot of money at Mouser and DigiKey. The other thing that we do that's very different from everybody else is you can put it together yourself. Most everything that I sell is available in kit form. And if you're a builder, you can put it together yourself. If not, it's available assembled and tested. And again, if it's built, assembled, and tested, it comes with the FCC guarantee that it passes Part 15B compliance. So we have some adapters that are available. There's some radios out there like the Alinco DR 135, 235, 435. They're a great radio for digital communications, and those radios are easily connected with a little adapter with the DRA 50 and a simple cable that you don't need to build. Similar concept for the Motorola Max Track Radius and CDM series. We have a little adapter that plugs in. It converts, again, that weird connector over to a standard mini DIN 6. And we just got done beta testing the BCM 6, was for the Bridgecom BCM, VHF, and UHF radios. And again, it's that particular one has a HD 15 connector that goes on the back of the radio and converts that over to a mini DIN 6. So the only cables that we actually sell at Masters Communications are mini DIN 6 male-to-male cables. We have two of them. One of them is 6 feet long. It's called the DRAC 12. And the DIN 6 shorty is a 3-foot cable. For those radio interfaces that need special cables, they're available from other vendors. Most of them are available from Tigertronics. So real quickly, this is what a DRA 30 looks like. The chip with the 48 pins in the middle is the C media chip. That's the codec that makes everything work. That's really the brains behind this particular unit. It's also the chip that creates the signal that makes the push to talk. So that's really the heart of this. And for those of you that want to know, it's called a CM119A. The chip that's below it, that's a standard 8-pin DIP, is a NE555 timer. And that's what creates the watchdog that keeps the push to talk from making the radio push to talk if it's lost communications with the host. That chip makes it so that the push to talk is inhibited and will not allow the radio to transmit. The DRA 30 obviously has a DB9 connector on one end and a USB on the other, and USB end obviously connects to the computer, and in this case the radio connects to the DB9. This is a DRA 39, which is basically a DRA 30 that you just saw, but it has a couple of differences to it. The biggest difference is its radio connector is an RJ45 female. The connector that's beside it that is round is the 1/8-inch female jack for speaker. So in this case, this particular DRA can connect to a handheld or any radio that has a microphone and a separate external speaker connection. It's just made to be easier to connect to some radios. It has exactly the same capabilities as the DRA 30. In fact, all of the 30 series, the 30, 34, 36, and 39 are all identical units. They just have a different radio connector on them so that makes it easier to connect to some radios. The next series is our DRA 50. And the 50 is actually the same as a DRA 30 with the exception of the two 8-pin ICs on the right-hand side. Those are LM386s, which are a small audio amplifier, and that makes the transmit audio capability much higher with this particular unit. The DRA 30 series basically has about 2 volts peak to peak, and the DRA 50, 45 and 50 and all the series above that have just about 4 volts peak to peak capability for those hard to drive radios. The 50 also has a mini DIN 6 connector on its output and is a great adapter for anyone that's got a data capable radio. So we have plastic 3D printed cases that are available in 6 different colors. Obviously this one's blue, and we actually 3D print them here. And they have a little sight glass there that the LEDs come up through a little piece of plastic that's like a filament, and allows that light to come to the surface of the lid. And they're really a neat, very protective case. DRAs are not prone to RF, so they don't really need to be in a metal case. And certainly there's hundreds, maybe thousands of them out there that are in plastic cases. And the plastic case obviously is the cheapest option. We also have metal cases available. So in this case, this is a DRA 50 that's stuffed inside of a metal case, and we call it the secure construction. Now, that's not why it's called that. SC stands for Scott Currie, because in this instance, Scott was the one that come up with this particular model of a extruded metal case, and he showed it to me one day, and he said, you know, I think a DRA will fit in this. And I looked at it and I said, boy, that's really close. That's really good. So we ended up having to build a couple of adapter rails to make the thing fit in there perfectly. But we get these end panels made. They are actually, believe it or not, they are aluminum printed circuit boards. So these end panels are actually made from the same people that build our boards, but they're aluminum. And everybody's probably going, okay, aluminum circuit boards, how does that work? So aluminum boards are not intended to have through holes. They're only intended to be used in surface mount applications where there may be a device soldered fast to it that needs to have a lot of heat taken away. So in this instance, that is exactly what the manufacturing scheme is and the silk screening that's done is just like the silk screening that's done on the circuit board. So in this case, we have DRA and a little place to write 50 or 70 or 36 or whatever in there. And when you get one of these DRAs in a metal case, the assembler will print the model number on there. They bend the LEDs so that they come out through, and the heartbeat and the push to talk LEDs come through the front. And here's the neat thing: the thing is all metal. The end panels are metal. The case is extruded aluminum, and they really look nice and they really work well. And they are the metal Scott Currie case. So here's a neat concept that kind of got us into building the DRA 100. So a lot of people said, okay, well, the DRA 100 is neat. What about this DRA SR? So the SR is the SignalLink Retro. And this circuit board is intended for people that already own a SignalLink. They already have the case and the knobs, and they already own the device, but they want to upgrade it to the performance of a DRA. They can buy one of these DRA SRs. They take and slide their circuit board out, their SignalLink circuit board, slide this in. We use exactly the same push button switch, exactly the same model pots, and everything is lined up so that it all works perfectly with your existing case. Now, yes, there are some holes out the back that aren't used. We don't have the aux, mon, and speaker connections on this board. So there's some holes out the back that end up not being used, but it's a neat concept. And it was something that I wanted to do. I had a couple people ask me, well, why don't you build something that, that goes in that case and we can reuse the case and save some money. So here's a product that does that. From that, we had other people say, well, that's great, but I don't own a signal link. I'd like to have one of these things. Do you have a case? No. But yes, we do. So we actually built a DRA SR that's a little bit different in size, and we call it the DRA 100, and it fits in a all metal case. Again, in this case, the front and rear panels are these custom circuit boards that we get made that are made out of the it's almost an 1/8 inch thick aluminum circuit board, and is silk screened, and they really look nice. It's a very professional looking unit that we're very proud of, and their performance is second to none. Out of all the DRAs that we build, this one certainly is the highest performance. So we've talked about DRAs and their compatibility maybe with other cables. So in this case, the DRA 39 and the DRA SR RJ45 and the DRA 100 RJ45, obviously they all have RJ45 connectors on. And the reason for that is we built a lot of DRAs up to this point, but we didn't have the compatibility with all of the different radios. Certainly Tigertronics with their signal link line have that covered very well. Their forethought there with different cables and these configuration modules is brilliant. And it allows people to buy a cable and a module and stick it in a signal link or one of these DRAs, and it configures the wiring up so that no matter what kind of a radio that you have, they probably have a cable available for it. So in this case, the images on the right hand side, we see a pair of DRA 39s. One of them have an older SL MOD 6PM module. That's the one that didn't have the 1200 9600 selection pin on it, and the one on the left does. One of the things that a lot of people don't know, because I've never advertised this, but for probably more than 6 months, we've been building cases that have a little slot that's covered. And the reason for that is if you own a DRA 39 and you want to change the baud rate and you don't want to take the case apart, you can take an X-Acto knife and you can cut out this little hole and then put a jumper in there with a handle, and you can change the baud rate without having to take the case apart. So that's a picture of how that's done. So this is the backside of a DRA 100. This particular DRA 100 is obviously the RJ45 model. The RJ45 connector here utilizes those signal link cables and modules. In this case, this particular DRA also has a speaker jack. So if you have a radio that the only way that you can connect receive audio in is through the speaker, there is a speaker jack on this model. So the next thing we're going to get into are the mixers. The mixer is a concept that was brought to us by Steve in Tennessee. Steve Waterman reached out to me and said, hey, is there any way that you can build a mixer so that we can connect Pactor modems and sound cards to a radio? And I said, yes, I have a mixer, but it's really not the right product. It needs to be refined for this. So Scott Currie and I went to work and we revised the original mixer, which was not designed by me. It was designed by another ham years ago as a project. And we took Walt's design and made it into whatever we needed to here to connect radios and sound cards and Pactor modems or TNCs. It'll work with anything. It's not limited in any way, shape, or form to what could be its input or what its output is connected to. And we have two different models. If you have a radio that has mini DIN 6 on it, obviously the one on the left is our DRA 3M DIN 6 model. The one on the right is the DRA 3M RJ45 model. I think it's obvious that the radio connection here is different. And if you have a radio that's got a DIN 6, use the one on the left. If you have a radio that doesn't have that, use the one on the right. It's pretty simple. This is what the insides of the mixers look like, the circuit boards. Here again, the one on the left is the RJ45 model. As you see, it's got a 16-pin configuration socket, and in this case, there are 8 wires that simply jump the input to the output. That's usually not ever going to work for you. Those wires are just put in there because our assemblers need that particular configuration to test with. But those wires are intended to either be reconfigured or taken out and a module from Tigertronics be put in that slot to configure the output wiring of the RJ45 jack. And here again, they have tons of cables and modules to connect virtually hundreds of radios. Also, you'll see right behind the silver connectors, you'll see some jumpers called JU1, 2, and 3. Those are the baud rate jumpers. And for shares operation, those need to be in the 12, which is 1200 baud position. We try our best to make sure that these things get sent out in that position, but understand when we test them in the 9600 position because that's the way our test apparatus is. And when it gets sent to you, we may have inadvertently left them in the 9600 position. So if you buy one of these from us and it doesn't work, I apologize up front. It may be simply that we need to take 4 screws out, slide the board out, look at these jumpers. Again, they're mechanical, no soldering required. They may need to be jumped in the opposite position and into the 1200 position to make them work. So this is a simple block diagram of how a shares RMS station is configured. In this case, we have a computer that's working WinLink Express RMS tri-mode with VARA HF. So VARA HF is going to be, in this case, what's connected to the what's going to be used with the Dragon modem. And in this instance, the Dragon modem is connected to the computer. A DRA is connected to the computer. It says DRA 100, but it doesn't have to be that. It could be a DRA 36. It could be just about any DRA. And all of those things get connected to the mixer, and the mixer is then connected to the radio. So what the mixer basically does is takes the 2 sources, creates one, and that's connected to the radio. The mixer is not passive, it's active. And that's why it's got a 12-volt power connection out the front. In this case, the mixer requires 12 volts DC. That power has got to be clean. We have had some instances where people have had trouble. And in most cases, the trouble has been because of power that is not clean enough to operate the mixer. So we do have a couple of powering options available. We have a 12-volt wall wart that simply plugs into a 110-volt outlet. We also have a patch cord, a 3-foot cable that you can connect up to a power supply or a battery, whatever that you have for your power source. So, but that gives a basic block diagram of how the whole thing gets connected together. Scott, do you want to add anything to this while we're here?
Well, there's, I was going to talk about it during the Q&A if anybody asked about it, but the question has come up that the Dragon, the 7800, has 2 radio connectors on it. One's the main, they call the main connector, and one is the auxiliary connector. They changed the firmware back a while ago that you can actually use the auxiliary connector as an input connector. So theoretically, you could do what we're doing with the mixer just with the 7800. A couple of people asked me if that'll work. I don't know the answer. I'm a little bit skeptical because one of the things that SCS did when they added that option, they run the audio coming in through the auxiliary port through their AGC circuit. And that's going to destroy the VARA waveform. So we haven't had anybody try it yet, so I don't know for sure, but I'm skeptical that it would work. So we'd still want to go through a mixer the way we're hooking up here.
Sure. At least go through the testing phase and see if it's even possible through the Dragon itself.
Yeah.
So anyway, that's it. We can I'm going to stop share and we can go to Q&A.
There were a couple of questions that came up while you're talking. I'll just comment on one of the questions was how do DRAs compare with the built-in sound card in a modern rig? And it's I think the quality is of the sound cards that are built into the rigs are probably very, very good. The thing that we've seen that is a drawback to performance-wise is that for whatever reason, the manufacturers seem to want to limit the bandwidth that their built-in card can do. So for HF applications, you probably wouldn't see any difference in performance, but if you're operating in VHF and UHF and you want to get that maximum speed out of VARA FM, you won't be able to do that with the built-in card on any of the rigs that we've seen so far. If you have the option to connect to an external device, then you could utilize a DRA or some other sound card device and get that maximum throughput. But we haven't seen any of the Yaesu or ICOM or Kenwood build a built-in card yet that can do VARA FM wide. Somebody asked about balanced audio a little bit, and Kevin kind of touched on this. The one place that we would want to use transformers, and that's in the commercial radios. So if you've got a Codan radio or a Barrett radio, they generally have balanced audio input and outputs, and so we would have to put and the DRAs are all unbalanced input and output. So, and that's the one case where we would add a transformer to the configuration so that you could have that balanced configuration. And I also wanted to mention the USB connector that we use on the DRAs is the big, ugly USB type B connector.
Printer cable.
Yeah, printer cable. And there's a good reason for that. There's some of the other interfaces out there use the micro USB or the mini USB connector, and that's just not a very tough connector. And when you get a cable on the end of it and you start wiggling things around, it's really easy to break that connector. And so we've stuck with the great big connector. Yeah, it's big, but it's sturdy. So.
Yeah, one of the biggest reasons that I don't do that is I have a friend that builds some radio interfaces, and he uses that particular connector on some of his radio interfaces, the mini USB, and he's had some trouble. And the reason is most of those connectors are not through hole. It's really hard, starting to really get hard to get through hole components in general, but they do make a couple of through hole mini and micro USB connectors, but they're really tough to come by. So most people are manufacturing the surface mount model, and there simply is not enough surface area on the connector. If you mishandle that at all, you break the thing completely off of the circuit board because there's just not enough material to hold it fast. Yeah, the USB-B is big and ugly, but it's got two great big pins that go down through the shield that go through the board and we solder that hole completely shut. You're not tearing that off the board. No way. So.
Okay, open for questions. And it doesn't have to be just about DRAs. I mean, if you have sound card in general, we
Okay, I don't see you.
we might know the answer.
Barry, you want to take it on the text?
Everybody, they've answered all of the questions in the chat.
Okay. Back to hands up. Let's get some hands up, folks. I don't.
In
see
reading the comments, I did notice that someone had mentioned the DB9 and thanking us for the compatibility with the existing cabling. And certainly that's the whole reason that we went with a different DB9 connector pinout from our RA series to our DRA series. We had a lot of people that had TNCs that were already in place, and they're like, hey, can I take my TNC3 and throw it away and plug the cable into the back of the DRA? Yes, as a matter of fact, you can. So yeah, that's one of the reasons that we wanted to do keep the availability of using cables. Most of us hams are, well, I probably shouldn't say cheap, but I'm cheap, and probably most of us are. So, we want to have an economical way of being able to connect things, and as we go from some of this elder equipment to this new stuff, it's nice to not need to solder another cable up. So if you have a Camtronics TNC and you want to try out a DRA 30, at least you can use the same cable. That is a good point. Thanks for bringing that up. I should know that.
Well, I might throw in here real quick. I'll catch you in a second, Tom. I have his products. I got a couple of his products, and I had a problem with my radio interfacing with the product, and I'm scratching my head. I thought it was the product. The radio was a $3,000 radio. Well, can't be it, right? And we ran out of software concerns, and so we pulled in Scott, and between the two of them, I had a $3,000 bum radio. I just had to get taken care of. But the support was great. There was no hesitation, just right there. And of course, there was nothing wrong with the product. And I do appreciate them and their time. Okay, enough of my blobbering on. Tom, take it away.
Thank you, sir. I just want to know, can I get a replacement metal case for my DRA 50? Will it work by just sliding the one in and the other out?
So you have a DRA now in a plastic case and you'd like to put it in a metal case. So here's the thing. We have made this metal case able to be used with boards that have already obviously been made in the past, but realize the LEDs are not going to be able to come through the front. Now, if you have the availability of changing the LEDs, I will bend them and I'll put them in the bag. So just send me a note that says, hey, I need a new pair of LEDs, and I'll send them to you for free. And then when you put that in, you can line them up, take the old LEDs out, clean the holes out, and realign the LEDs so that they come through, and then you'll have what we've shown you here. Now, understand there's no necessity of doing that, because where we've positioned the holes for this, you can look through the holes and you can see the LEDs that are in there. So even if you do not want to or don't have the ability to change the LEDs, you don't have to. You can still peer through the holes and you can see the status of those LEDs without needing to do anything. Now, understand that the board does not just slide into the new case. The case is slightly wider than the circuit board is. So we've made some adapter rails that simply bolt on with a couple of small screws and that makes the board wide enough that it fits in. Scott's showing you the difference in the width of the circuit board there. I think the board that he actually has on his left side is a mixer, and the one that's on his right is probably a DRA of some kind or another. But anyway, because there is a difference in that width, we do supply everything that you need to be able to configure it to slide it into the new case. And the cases are available all by themselves on the website. So you just have to, there is a choice because there's different connectors require a different end panel. You just have to indicate which type of a connector you have. It looked like you had a DRA 36 or a 50 or a something.
50.
Okay, so a 50, you just need to make sure when you order that you order it with the DIN RJ option. That's a pull down on the menu and select that and you'll be good to go.
Again,
One suggestion.
any questions, if you got any questions, just email them and or call them and you'll get the answers you need.
Sure.
One suggestion,
Yeah.
at least there were loose site push-ins available for your hole problem, where you push them into the hole after cutting them to length, and there's a little shoulder on them to keep them from going inside.
Yeah.
And you just cut them to length and they bring the light from the LED out.
Yeah. I wanted to do that, but that ended up being a lot more difficult because the manufacturing process does not, with plastic, that fits together and it doesn't have to be perfect. With the metal front panel, I couldn't get it sized that it always fit well. Was almost going to have to glue them in, and the ones that didn't fit tight enough. And then I had some that the manufacturing process, they were too tight. You couldn't actually physically get the thing in without using a knife or a sandpaper or something and whittling the thing down. And I'm like, you know what? We'll just bend the LEDs and stick them through and it'll look nice. And it does. So that's really, the reason why we went with the method that we did was so that it looked good and the LEDs peer out through. And, but I did try that method. I really did.
Okay, Scott Reed, KM6 RFB, you want to take it away?
Hey, Scott, good to see you.
Hey.
And Kevin, hey, I just want to say that both these guys have been super supportive. I've had a couple things and they've been very responsive and very helpful in my projects up here with the state. So my hat's off to you guys. Thank you.
You got your gateway on the air yet?
Getting closer. We've been kind of playing with water falling from the sky here recently.
Oh yeah, well that is a problem.
But getting closer, getting a lot closer to the process, and it's just getting the people on the higher ups to cut loose some of the purse strings. But thank you guys, I really appreciate it.
You're welcome.
All right, Steve Waterman, did you want to add anything to this conversation?
Oh, I'm no engineer, but I can tell you that the physical quality of these things is superior to anything else, any other non-LED sound card that I've run into. And from all indications on the share system, they are working expertly. And the reason why I called to get some agencies don't solder. They don't do kits. So I needed to have some at least professional looking or plug and play devices. And these guys produce these things so fast. It's not easy these days, and they did it. And I got to commend them for that. I've had a mixer here, the new mixer and the DRA 100. For those people that do run a radio message server that have at home or at work that have kids or curious my standards, it's always a good thing to consider buying a device that is secure from having knobs being twisted. So if you have a signal link sitting there and somebody walks in and says, and starts playing with the radio and the knobs and what have you, that's not good. So it's a wise thing in an environment where you don't have total control of every minute of the day, that they have built devices that you just can't walk up and start twisting knobs and screw things up. It's the small companies like this that make individuals like us appreciate what they do, and that's no small case here. Kevin has really got a good thing going, and I hope he continues this process until he's old and gray, and Scott until he's older and grayer.
Well, certainly, Steve, without your foresight in this project would have never happened. I think you need to be commended for all of the things you do where shares are concerned. I can't imagine the workload that you have in administering and trying to make sure that emergency communications work as well as they do. I know that from what I have learned about shares in the past several months, that has to be a daunting task. And you're certainly a guy that is up for it and ready to handle anything that gets thrown at you. And we certainly have appreciated being able to work with you in this concept and make something, that hopefully can get more people involved in the shares program and not have to spend a lot of money.
Well, I appreciate that. Shares is a non-amateur service, and there are many non-amateur services in Wind Lake. Last night, I gave a presentation to the country of Canada. They're considering a similar application where they can utilize volunteer resources. So this whole thing is growing rapidly. You better get yourself a warehouse.
Okay.
I know Florida property is expensive, but
Depends upon where you live and what the disaster's running through at the time.
Yeah. And for those who are not sure what Steve and Kevin are talking about, the previously shares, which is the shared resources HF system, only allowed Pactor as the primary protocol, and they've just recently added VARA HF to that configuration, to the acceptable protocols. And so that's what actually drove the development of the mixer, because the gateway operators and actually the client folks want to be able to have both a Pactor modem and a sound card connected at the same time to the same radio. So that's what drove the development of the DRA 3M.
I made an announcement at the beginning of February, and now there are 32 radio message servers that have both Pactor and Vera out of 117 on the share system. So it's catching.
Yes. I might add that I have the Vera SR. I had the older single length that had the big transformers and wasn't going to do the job I wanted. So I decided to pick up the opportunity to swap out the board was one that would work for what I needed. And when I saw what I had, I got a hold of them and I says, couldn't we put a switch in the back of that thing? It looks like there might be room so that we can transfer 96 1200 baud without even having to worry about the case. And he said, oh, no problem. And he took maybe a 3D back for it and everything. It was just easy. So they work with you and they do a great job. Okay, Jim, I've been not avoiding you, just yakking away. So you want to take it away, sir?
Yeah, just a couple of things. We have a DRA 50, DRA 45. Hopefully we'll get a little bit of money. It's really hard to get, just a couple $100 from the state of California. It's easy to get millions, but you can't get, small amount of money. Anyway, we're working on it. But we found the handshake using Vera to be really fast. And so I think the DRAs in conjunction with using Vera on WinLink is just a great combination. And I'd just like to add that it's not only little kids that'll come in and twist knobs. We got big kids that come in and twist our knobs in our radio room. Back to net.
Yeah, kids come in all sizes.
I do want to make one comment about that. Steve had mentioned the DRA 100, and of course it does have knobs on it like a signal link. But really, what I would really like people to consider with, if there's anybody here that's going to do a shares deployment with VARA, there's really no need to spend the money on a DRA 100. The DRA 36 has the same capabilities for VARA HF as does any of them. And in fact, when used with the mixer, any of the downfalls of the DRA 36, if you can say that they have one might be, well, it doesn't have a relay. But when you put it behind a mixer, it does have a relay to push to talk.
Amplifier.
Yep, and it doesn't have amplification, but when you put it behind the mixer, it does have amplification. So there's really no downfall at all to using a DRA 36. And the nice part about a 36 in a metal case is there's no knobs to turn. You have to take it out of the case to adjust it. Now, hopefully you're only going to do that one time and get your audio level set right. You put it together and you let it that way. And in these places where you may have people that you're not sure if they're going to be monkeying with things, please consider a standard DRA. The 36 is really the right model to use with the mixer in a metal case, and no knobs to twist.
All right, Steve, you got your hand up. You want to take it away?
Yeah, I just want to make one comment here. We talk about the price differences, and agencies don't like to spend money. And when you consider, as I have always said, an entire station, including a Pactor modem and maybe a Honda generator, along with a drop kit and a radio and everything else, the whole thing costs less than one P25 Motorola handheld. So if you put it in that context, we're not talking about a lot of money here in the United States, but we just signed a non-amateur service up in Poland recently and some other places in that area. And let me tell you, it makes a huge difference. I think with software-defined radios and these non-interleaved sound cards, and I think, and the amount of software that's taking the place of other things, I think that that this is just a pathway toward what AM radio's headed toward, or all radios headed toward. So congratulations to you guys. I think it was back in 1980, maybe whenever Windows 3.1 came about. Who knows? I can't remember. And anyway, back in that day, the original design for this mixer was a big, huge aluminum box with phono plugs and a few transistors and resistors and what have you. And what these guys have done is, to me, a miracle. But I'm no engineer.
Well, you see the results, and that's what
That's what matters, right?
Thank you. We appreciate it for sure.
All right, Scott, you got anything more?
I don't. I think we've covered it all. There's no other questions.
Okay, if you guys are on the WinLink and you got problems, you'll probably hear from Scott. He was right on there, just right on it. I monitor the WinLink thing, and he's a busy boy. He takes care of left and right. Okay, back to you, Kevin.
All right.
One other thing here, if I may.
Sure.
We have a reflector where Scott is one of the moderators that's called the WinLink Programs Group. If you go to the WinLink website and go to the support page, you can join from there. There's 3,000 opinions on there. And because of people like Scott and Tom Whiteside, N5TW, and Thomas Noel, and a bunch of others, that really know what they're doing. If you need any assistance, and Kevin is busy building, there is assistance there. So don't ever hesitate to go, whether you're a WinLink user or not, you can go there and get all the help that you need with respect to does it work with this or does it work with that?
Okay, Dan, you got your hand up, sir.
Yeah, I want to follow up on what Steve just said. I make it a habit to read the what is it, Windows for Programs Groups IO the minute it pops up. And just following that for 4, 5, 6 months is a great education, because everybody else is going to ask them the questions that you need the answers to. And I'm as lazy as can be, so I'm just picking up on all the good answers you're putting out there. And another thing, well, I got a question actually for the group, only partly related to this. In talking to somebody about WinLink, there was concern about, what would Vera FM do to Packet? And only way I could think to explain it was, well, there's a great similarity between AX25 Packet and Mother's Milk, in that you really, if you don't have it, you're not, to get off to a good start, you have to have Mother's Milk. And Vera, on the other hand, is what you're really going to want to do. I've been monitoring one gateway that supports both Packet and Vera FM. I don't know, 3, 4, 5, 6 hours a day for several months now. And he was concerned about, if they up the amount of WinLink they did in their group's training and everything, that the gateway would be overloaded. And I assured him that, I'm not hearing one transaction per hour even. And just to go ahead and, do the packet if that's what you and your people can do. And yeah, the best investment you'll ever make is a license for Vera. You get, by the way, WinLink has improved dramatically the last couple of months. So it made me lazy. And when they came out with Auto Connect, and it's not near as exciting as saying, well, gee, how far can I go today? With the current propagation, you just fire up AutoLink, and both on Vera and Pactor, it gets sent unless you've forgotten to do something when you set up the system. So, kudos to all of you for making it go this far, this fast.
Well, thank you, Steve. Dan, rather. So I'm looking at Steve. Steve, you got your hand up. You want to do it? Take care. Go on board. Steve?
Good evening, Kevin and Scott. I've been a beneficiary of each of yours teaching and wisdom, and I appreciate it. I've got two. I have a VHF RMS gateway, and I have a packet node and BBS, both running on DRA 50s. The VHF RMS gateway is both VARA wide and 1200 baud packet. But I'm now changing my shack VHF UHF configuration from an FT991 alpha with a built-in sound card to an FTM 300DR. And I've got a DRA 70 I built, and in fact, it was the first project I undertook with Kevin's products and his fantastic support, even until looking at photos I sent him before I powered it up. But here's the thing. The Yaesu radios all use this custom 10-pin mini DIN. They sell an adapter, a CT164, And then you can go from that adapter to 6-pin mini DIN to 6-pin mini DIN. Well, I'm an emergency doc, and I spent 43 years in the ER, and I don't want to tell you the number of times tube connections came apart in the heat of battle. And it's been my experience in 60 years in amateur radio that cable connections sometimes come apart. So I'm going to make a small plea that you source, because I've been unable to discover someone who makes a mini DIN 10-pin to mini DIN 6-pin 3-foot or 6-foot long cable. I'd really appreciate it.
Well, I'll address that in saying that I don't think that it'll happen. And the reason for that is, unfortunately, the mini DIN 10 that is on the Yazoo radio is not a standard mini DIN 10. It's a proprietary mini DIN 10. And I've not been able to find any connector that really fits it properly. So because of that, I don't know that you're going to find any adapter or cable that really fits properly. There's some people that make some stuff out there that they say will work, and yeah, you can jam it in there, but it doesn't fit like the connector that you get from Yazoo, because it is a proprietary connector. So I wouldn't make it anyway, because I don't make cables. That's one of the first things that I generally tell people when they want a custom cable. I'm pretty quick to say I apologize, but I don't make custom cables. I only have 2 cables, and of course they're the mini DIN 6 male to male cable. But so I'm afraid that you're going to have to go with the CT164 and adapt that accordingly with whatever length male to male mini DIN 6 that you need. Maybe some tape would help you in that instance. I'm not sure.
I think you're muted again, Steve. Yeah, I don't know where the industry's going on this. You know, it used to be that most of the radios had the mini DIN 6 on it, and now we see fewer and fewer radio manufacturers have that connector on there. And you know, in the case of Chemwin and ICOM, they're just not even putting the interface there. At least Yaesu still has an option there, but I don't know. I think we need to make some noise at the other manufacturers and say, hey, we still really want to be able to connect other devices to our radios. We really still need that connector or something similar to it.
I didn't really want to bring this up, but Kevin, your competitor, DigiRig out of Texas, in fact, does make a mini DIN 10 to tip ring shield cable for their device, which of course has the defect of using the second COM port. Anyway,
Yeah.
Off the air. Thank you very much.
I'm not sure where they're sourcing that. I had been told that possibly they are modifying their connectors to work properly. And if that's the case, kudos to them, to whatever it is that they may be doing to make the connector work correctly. I can tell you that if you buy a mini DIN 10 and try to plug that into a Yaesu radio, it just doesn't work. It doesn't fit well. It's not good for the radio. It's not good for the connector. So I'm not sure what they're doing mechanically, or they have figured out where to source those, and I have not. So that certainly may be the case, that they're able to source the correct connector. And if they are, that's great, because their stuff does fit correctly. I can tell you that. I know that for a fact, that when working with some other people that have said that it does work.
Both of you are looking over chat, making sure we don't miss anything. I don't see any more hands up.